All right, what's going on? Back with another episode right here. Just going through my case studies. This is like a nice short one today. I wanted to get something out there for you guys. This was a nice little interesting diag and really shows the importance of doing relative compression testing. It's very simple to do. It's easy. It just requires having an oscilloscope, but if you have that, it's just an easy test to do and could just save you a lot of time. So this vehicle was a 2016 Audi A6. It was brought into the shop for a misfire issue. It was a dead miss. You'd start it up. It was running really rough. It felt like you had a coil unplugged, like a secondary miss. The shop stated that the customer placed a bunch of parts on this one, but they weren't 100% sure what work was done. They said it looked like new coil packs have been installed, and they said it has a misfire on cylinder number 6. Now, the shop told me that they pulled the plug, they found it incorrectly gapped, so they re-gapped the plug, and the misfire is still present. This is when they called us in, just to let me diagnose this for them and tell them what was going on. So, first thing I did on this one was obviously confirm the issue, started the car up, and I felt the miss right away. So that's a good sign. I hate doing misfires. When you get there, you start it up, and it's not misfiring, and then you drive it around, and it just turns into kind of a waste of time. So if it's not actively misfiring, there's really nothing you're going to find on it. It has to be actively happening. So I'm excited when I get to a car for misfire and it's actively misfiring. I have something I could find, and we'll go from there. So first thing I do is verify that it's actually misfiring, which it is. Then I took a pre-scan of the vehicle here. Now there's a bunch of codes in here. Keep note of some of these are active, some of these are passive. You want to keep in mind the state of the code, see what comes back. We are really only concerned with a couple of these. So we had cylinder 6 misfire codes, right? And then we have some other codes in here as well too. But they were really just concerned with the misfire codes, and those are what we're going to take care of first. After that, we'll clear all the codes, test drive it, and then see where we're going to go from there. Pulling up live data was the next thing to do here. So we pulled up live data, and we have just cylinder 6 continuously counting on the misfire counter. None of the other ones were, and this was just continuously counting, verifying that it looks like we are indeed looking for an issue on cylinder number 6. First thing I did on this one was just quickly, you could go about this like one or two ways. I like to check wiring on it, just something I like to do. I like to verify wiring and hook up a spark tester just to see. I ended up pulling up a wiring diagram. Volkswagen Audi's wiring diagrams are quite different than the redrawns that you'll find on like a Pro Demand or an All Data. So these are like quite different. If you've never used these, they're a little bit, you have to kind of learn how to read these diagrams. There's like numbers on the bottom, and you gotta just trace things back. So basically right here, we have N324, which is ignition coil number 6. And we have pin number 1 is the power. But in order to like find this fuse, you kind of got to go through a little roadmap. So this basically comes up here, D102, and then it comes over here to D117. And then there's these numbers at the bottom, like 113. And basically what you're looking for in this is this is a continuation here. This D117 is just like slightly cut off. But that's where this one goes. And then you see this 54 over here, right? And these are the other, these are some other components here. So what do we have? These are coil 1, 2, and 3 for N70, 127, and 291. So these connect, and this goes, so you basically have 3 coils here, right? And then we go to the other 3 coils here. This goes to 54, which are going to go on these bottom numbers here, find 54, and then you'll see, just draw right up, you'll see 112 here. Now, if you go back and look where we saw that 54, you'll see 112 at the bottom. Right, so it's kind of like weird how they line up, but that's how they use it. I forget what these are called at the bottom. They're like call-outs or something. These might be called track numbers. Anyway, it's unimportant what they're called, but this is right here what we'd be looking for. So SA14, this would be fuse 14 on fuse panel A. You see this would go to 112, so now we come down here to 112, and you see 54. That's where we just came from. 54, 112, and then there's the connection here to here, and then these are the other 3 coils. So we checked I checked the powers and grounds at this coil. There was no issues. Everything was good. And then you see we have like our ground 2, like we have 201. This goes back to 601, which is ground connection on left cylinder head, and so forth. You could follow the diagram to find everything you need on what this is. We have control wire here, pin 3 from J623, which is the engine motor control module. Definitely a little bit more complicated using this style diagram than just like a redrawn. but I do kind of like to challenge myself to use these OEM diagrams. I don't see how it would fault you just trying to learn different diagrams. So I like to try and learn new things. These were very complicated when I first started looking at these, and I didn't really understand them a lot, but the more that I look at them, the more familiar I get with them, and it's just like anything else. So I checked powers and grounds. Everything was good at this coil. I had good control to it. I put a spark tester in it, and I had great spark coming all the time. So that pretty much led me to my next stage. So I did notice that when I removed the spark plug, there was excessive fuel on the plug. My next step in this, since I'm not seeing anything with spark and there's fuel in the plug, so it does have fuel, I'm looking at performing just a relative compression test. It's pretty easy to do. There's a couple ways you could do it. The way that I do relative compression testing is I just put my 2 leads across the battery, positive, negative, and essentially you're just like watching the battery voltage drop on compression. Obviously, when you come up on compression, the starter is going to have to use more current to push against that load that it now has. So that's what's going to create these peaks and valleys across this waveform. So the blue channel here would be my positive and negative across the battery. This is obviously battery voltage right here. And this is once I start cranking the engine over, we drop down a lot using a ton of voltage to turn the motor over. And then once it kind of stabilizes, it makes this waveform here. And as you can see, we have like this one pattern. So this red trace right here is just that coil 6 control. So I'm just probed in there. So I have like a reference of that's the cylinder that I'm going after. So I kind of want to see where that falls along my relative compression waveform. So you could see each spot that that cylinder falls is not building compression. Essentially, when you have your voltage here, this is like the voltage drop as you're having compression on the cylinder. You can count these, right? Figure this is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you're verifying that like every 6-1, you're on it. So everything lines up like that. So after seeing a waveform like this, it's pretty much you're going to be going to look into compression. So this is pretty much as far as I go on this. If a shop really wanted us to go further in depth with testing, we could go further in depth, but a lot of the shops that I go to, this is kind of all they're looking for, just a direction of where to go. So now that I pointed them in this direction, they're going to go and hook up a mechanical compression gauge. They're going to check, do leak down and so forth and look. So in this case, I recommend to the customer, put a little bit of oil into that cylinder, crank it, and then check compression again. And basically with that, you just want to see if compression's coming back. If it does come back, it could indicate that the cylinder walls are washed from excessive fuel and they could be looking at a fueling issue. You'd be wanting to do like a injector balance test, something along those lines to see if there's any issues with the injectors. As for this car did have a lot of miles on it. It was like 210,000 miles, I think it had on it, and it was the original motor, so they're most likely looking at some type of internal issue on this one. So I'm pretty much just going to wrap this one up here. This is a nice, easy, simple one. I really just kind of wanted to show the importance of relative compression, some of the uses of an oscilloscope, but they're very valuable tools to have. So that's pretty much wraps this one up. I really think this shows the importance of doing relative compression testing. It's like super easy to do. The only things that you have to do is just disable the fuel. You don't want to have the car running per se. It has to just be wide open throttle and just cranking with no fuel. The spark doesn't matter as long as it's not running. What's really nice about Chrysler and some vehicles is they have a clear flood where you could put the accelerator pedal to the floor and it just kills the injectors and allows you to perform this test, which is really nice. Other cars, you have to pull fuses out for injectors or the fuel pump module itself just to disable the fuel, and then you could perform this test. So nothing really too crazy to perform this test. Some scan tools, I believe like Ford has it built in where you could set it in a relative compression mode and it will kill the injectors and the fuel supply, so you could run this test. So this is just the way that I like to do it, having my leads across the battery and then a sync to whatever cylinder I'm suspecting. You can come over to like Pico. They have a whole thing on compression testing. This is another program I do have too, Pico Diagnostics, and you could get kind of like a nicer view on what the compression looks like. You could also hook up a WPS to this to get like actual pressures, and there's a lot you could do. You could get very involved, as I'm sure anyone that's looked into scope related stuff, you could get wildly involved with how much stuff you want to do. This is another method too. You could use an amp clamp going around the positive cable, and you're just going to be measuring current instead. You get a similar waveform. it's pretty much the same thing. I used to do this when I first started off, and then I stumbled across just doing it with my probing on the battery, and I kind of found the same results every time I did it. So it just seemed a little bit easier to do the battery terminals, because a lot of times like my amp clamp might be dead, then I got to put a battery in it, and I just always leave them on. They always die. That pretty much sums this one up. Just wanted a quick little video. There's a lot of cool stuff in here you could do with the scope, but scope is a very useful tool. I think everybody should have it. I'm constantly trying to watch videos to like learn more different things I can do with it, and you know, just advance my skill set on it. Definitely plays a huge role in modern cars these days with diagnosing issues, and just one of those things that makes your life a little bit easier, so you don't have to go down a rabbit hole. You know, you could have this is something you could easily look at a bunch of these and throw a bunch of parts like some coils and some plugs and an injector and go through a bunch of different things and have no real direction. Nothing gets fixed. So something as simple as just pulling out the scope and hooking this up, you have a clear direction of at least somewhere to go and what you're going to find. That's pretty much going to wrap this one up. Kind of just wanted to come on here for a little bit, give you guys something out of my case study log. Hope you guys enjoyed this, and I'll catch you guys on the next one.